Okay, so let's kind of talk about our schedule. My board, people have walked by it so much, it's like starting to erase, but I know, right? No, like the people that sit by where Ryan is, like they get their backpacks and then they like brush up. So today and Monday, we're going to talk about the real number system. Tuesday, we'll review for Thursday's quiz. Since we have map testing on Wednesday, yes. Tuesday will be our review day. And then Thursday will be our quiz. Okay. After the quiz, we have 2 more sections to learn, and then we'll prepare for our CSA. Okay. So today and Monday, we're talking all about the real number system. Now, some of you are laughing, like real numbers. What do you mean they're fake numbers? When you get to Algebra 2, you are going to learn about something called imaginary numbers. Like that is a thing. Okay. Imaginary numbers are fake. They're not fake. They're imaginary. Fake, yeah, fake. Like some of them. Fake. Okay. Okay, so real numbers. The set of numbers containing what we call rational and irrational numbers. Yes, I will teach you, and you will need to know the difference between an irrational and a rational number. That's our big focus today. Okay, so what is an irrational number? We're going to talk about an irrational number. Okay. An irrational number, if we're looking at a decimal, okay, the decimal never, okay, decimals that never terminate. What does terminate mean?
Like the Terminator or like get away. Oh, that's Easter.
End. Terminate means to end.
Oh, that's right. I said it right.
I mean,
I said kill.
Okay.
Kill and you're ending someone's life.
We're ending the number. Okay.
So it never ends in a
And there's no repetition. So the decimal goes on forever and doesn't have any repeated like patterns. Okay, so I'm going to show you examples and I'll pull up my calculator so you can kind of like see what that looks like. Okay. All right. So an example, the most famous irrational number is the number pi.
Oh, I said that.
So I'm going to pull up my really cool calculator here. And when I put in pi, we get 3.141592653, and it just keeps going and going and going and going and going. And notice how there's no like pattern in these decimals. Okay. Another irrational number is the square root of 3. Now we've talked about the square root of 3. Okay, and we worked on estimating where this was going to be close to. We know that the square root of 3 is going to be close to what number? say 2, okay? Because the square root of 4 is 2. So the square root of 3 is gonna be close to 2. Now, if I punch in the square root of 3, okay, notice how I get a decimal. I can't really zoom in. 1.732050807.6, and it keeps on going. My calculator can just only show so much, okay? So that decimal keeps on going, and notice how there's no pattern to it, okay?
Whoa. Wow.
Okay, my 7th period.
Yes, I can hear you through the wall.
Hmm.
Okay, that's just what someone. Yeah, you guys are wild. Yes.
Okay, Ryan, can you give me an example of another irrational number?
6.
No.
7.
So square root of 3 is an irrational number.
Oh, 2.
Like the square root of 2 or 2. Okay. Any square root, any radical, like a square root or a cube root that doesn't have like the perfect square underneath, or a cube root with not a perfect cube underneath, like the cube root of 10. Okay. If we have a square root without a perfect square underneath, a cube root without a perfect cube underneath, it's going to be classified as an irrational number. Okay. It's going to give us a decimal that's really long. It never ends and doesn't repeat. Okay. So now, Ryan, can you give me another example?
20.
Just 20?
Yep.
No.
No, 3 over 20.
Like the cube root of 20?
Yeah.
That is how we would say that. The cube root of 20. We'll get there. Now, rational numbers. Rational numbers, I want us to think of fractions. If a number can be written as a fraction, so a fraction, you know, is like A over B, right? If we can write a number as a fraction, it's a rational number, okay? Now, not all the time are we going to have a fraction. It could be like you could take 5 divided by 6 and get a decimal, right? So if we have a decimal, it's going to be a decimal that terminates, that ends, or it has a repetition. Okay. And I'll show you what I mean by that. So anything that can be written as a fraction. So 5 over 7, is that a fraction? Yeah. So that's an example of a rational number. Okay. -1.5. Is that a fraction?
Yeah.
Yes. It can be negative, it can be positive, doesn't matter. That is an example of a rational number. Now, about 5. 5 over 1, exactly right, Arisa, very nice, okay? If it's just a number, like 5, 17, -3, those are all rational numbers. Okay? Now, what about this whole, like, decimals that terminate, or, that's an or, have repetition? So a decimal that terminates, this would be something like 1.25. And that's the end of the decimal, okay? Well, I know some of you might recognize this as 1 1/4 or 5/4, okay? We can write that as a fraction. I'm not going to make you, but if you recognize that this decimal doesn't keep going, how could I maybe show you that the decimal keeps going? Let's go back up here. If we have something like 3.145 dot, dot, dot. Those dot, dot, dots mean it's gonna keep on going and going and going. Okay. Now, what if I said 0.6 with this line, dot, dot, dot? What does that mean? Okay, so that's 0.6 repeating. And so that dot, dot, dot means it's keeping on going. But since this line is above the 6, it means there's repetition. So that's okay. If we have repetition in our decimal, we can still be that rational number. Does anybody know what number that is? 0.6 repeating. 2/3. That's what I was going for. Thank you though for letting me know that that was 6. Okay. So I brought my mixing bowls here, guys.
Are we gonna make something?
I wish. Okay. Now, within our rational numbers, we have little pockets.
a puke bowl?
No, none of these are pupils. Yes,
I don't know.
that's fine. You're gonna miss some stuff, but that's fine. Okay. Okay, so within our rational numbers, we have some what we call subsets. Okay, so I'm gonna start with our integers. Our integers. Because it continues in both directions. So negative, positive, 0, but numbers that, how do I want to say it? Like we don't have pieces, like we don't have, like we can write these as fractions over 1, but we don't have like 1 1/2 or, okay. Now whole numbers, does anybody know what whole numbers contain? Or what do we like erase from the integers? Negative. So whole numbers start at 0. And then natural numbers, what gets taken away? Yeah. That's the only other thing I think. 0. So the natural numbers are like our counting numbers. These are the numbers that you learned as a kid. 1, 2, 3, 4, 5. Okay. Our whole numbers are 0, 1, 2, 3, 4, 5. And then our integers, you got to be in like, I don't know, second, I don't know, sometime in elementary school. Okay, then you start talking about your negative counting numbers. Okay. Then you get to like 6th grade and you learn all this stuff about fractions. Those are our rational numbers. Okay. Now, what's really cool about this is that these are all like related together. Okay. So we have, I want you to come down here. We have our irrational numbers. Those are separate. Okay. We have our irrational numbers. It's its own little bowl. Okay. Corin's pupil. It is. You're right. This is what I use when I make like scrambled eggs. Okay. Now, we then have, I'm going to start with the smallest. We have our natural numbers. Okay. And here's our natural numbers. Okay. 1, 2, 3, 4. When you go to kindergarten, these are the numbers that you learn. Okay. Well, then once you figure out how to count, right? Well, then we add in, okay, what's this concept of 0? Okay. So those are are whole numbers, okay? Now, all of the numbers that are in my natural numbers fits in my whole numbers, but there's just one number really that's in this bigger bowl that can't fit in here, and that's 0. Okay? Well, then you figure out what the heck a negative is. And so we have integers, okay? Well, all of these numbers can fit in my integer bowl, okay? But the integer bowl, it's a little bit bigger because it has rooms for like -1, -2, -3, all of that. Okay. And we have all of these are contained in the rational bowl. Okay, but our rational bowl is a little bit bigger and has room for all of those fractions or decimals that terminate or decimals that repeat forever and ever, like 0.6 repeating, like 2/3, like 1 3/4, all of those numbers. Okay. So this is what I want you to do, because I know this is like really weird right now. I want you to think of a place that you really like to go. We're gonna come over here, right here. I want you to think of a place that you really like to go. So I really like to go to La Vista Middle School. Okay?
Are you lying?
Maybe there's like, you have a favorite restaurant, maybe you have a favorite place. Like I want you to think of like a building or a park, something like that, a place you really like to go to, and write it down, really small. Your house is fine. Okay. House. Okay. Then this is what I want you to think of. La Vista Middle School is a little building, right? That is in La Vista, Nebraska. Okay, so La Vista Middle is in La Vista. La Vista is in the state of Nebraska. She loves my Nebraska guys. Pretty good. Okay. That's research. And Nebraska is in the United States. I mean that.
Snake.
That does not look like the United States, but I really don't care. Okay. I want you to share with your elbow partner what you drew out.
Exactly.
Yeah.
I drew out. I just drew
You're safe. You're just your.
I should have done.
Okay, so boys are attention, back to me. Bronson, what location did you choose? Village Point. Okay, so Bronson, is Nebraska in Village Point? No, that does not make sense. Nebraska is Nebraska in Village Point. No, Nebraska or excuse me, Village Point is in Nebraska. Okay, Brady, what's your location?
My house.
Okay, is your house in the United States?
Yes.
Yes. Okay. Is Nebraska in Papillion?
No.
Okay. Are you feeling me right now? Okay. So the natural numbers is like Brady's house.
My house. My house is the biggest one. I own everything.
Inside of the whole numbers, Papillion.
And then there goes
Inside of the integers, Nebraska. Inside of the rational numbers, the United States. Okay?
Yeah, what about him?
That's
He's lone wolf.
That can be
your
your
That can be my bedroom.
Nope, this is separate.
Is it like a whole different country?
So this is like the airplane that's flying to Germany. I don't know.
That way.
Okay.
Is that Germany? Yeah, Germany's. I don't know.
Okay, so let's come back to this, all right? So if a number is in the natural numbers, then it's also in the whole numbers, integers, and rational,
Why'd you throw?
okay? If we have an integer, it's also a rational number,
Okay.
okay?
So basically, like the natural numbers, like everything. Yeah.
Okay.
But irrational is nothing.
Okay, so let's go to the next page.
You're rational.
Okay.
All the little numbers. This is you actually by
Okay.
yourself going to Germany.
Negative 47.
Wow. That's a big number.
Negative, hold on. I want you to think of the list, okay? Can negative 47 be considered a natural number?
No. I'm so tired.
Can negative 47 be considered a whole number?
No.
Can negative 47 be considered an integer?
Yes.
Okay, so it is an integer. Let's write it.
Oh, now we have to do it.
Oh, up here.
But Brady, it's also in what bucket?
Rational.
So it's an integer and a rational.
Why do they like make like math words like I don't know how to do something right.
Right.
Are we never gonna do anything with him?
Who else?
I was just gonna say here by
That can be Brady's
2
house.
and 3/8 is our next one.
That can be a.
Okay, so first of all, I noticed something about this one. It has
a fraction.
a fraction,
Well,
Say they have both.
yeah.
but it can't be a whole number.
Don't give attitude.
And have a- okay, so is this a whole number? No. Can I say that it's an integer? No, but we can say since it can be written as a fraction, it's a rational number. The absolute value of -9. Ryan, what is that? What's the absolute value of -9? Good. Okay, so this actually equals 9.
So
Okay, well, I know that it's not an irrational number. Okay, I'm not gonna worry about that. So let's think about here. 9.
it's a.
Can I put 9 in the natural numbers, the counting numbers?
Yes.
Oh my gosh, I can.
Oh my God, I own it.
So, if it's a natural number, then it's also a whole number, and it's also an integer, and it's also a rational.
Zero.
Where's an irrational number again?
What is an irrational number?
Oh, something that never changes.
Okay, so square root of 23. Okay, so I have a question. Is 23 a perfect square? No. No. So this is going to be a decimal. Is it gonna be a decimal that stops? Nope. Is it gonna be a decimal that has repeats? If this guy is not a perfect square under the square root,
Yeah.
Irrational.
it is irrational.
I got that so right. Okay, do not say it's irrational.
1.5625. Well, I can already take away these 3 buckets because it's not an integer.
Katie with a. Go, sorry.
Oh, so Brunson says rational because the decimal ends. Do you agree with that? Yeah, I
Oh
love
my
it. So we'll put that in there.
Rational.
Okay. All right, 0 is our next one.
0.
But it's not a natural number?
No.
No, but it is a whole number. Okay. Yep.
I can't smell.
Guys, I'm having so much fun.
What?
I'm having so much fun.
Wait a second.
Negative square root of 64.
I'm sorry.
Now, don't jump to conclusions because 64 is a
Is a
square.
perfect square.
Perfect
Arisa, what's the square root of 64?
square.
Good. So this is really negative 8. Okay, so Jada, you're saying that not natural, not whole.
I'm not, 'cause I don't know.
You're right, it's an integer. Okay, no. It is an integer, and if I put it in the integer bucket, it's still a rational number. Okay, next one.
Oh, it goes on.
Negative 0.123, but Bronson, what does that bar above 123 mean? Ooh, so it goes on forever, but it repeats. Yes, so since it has repeats, it is rational. Okay, 2 more. Negative 24 over 6, sweet, it's a fraction. Oh, but it's a fraction that we can actually reduce down to negative 4. So, because it's actually negative 4, yes, we can put it in the integer bucket. And if it's in the integer bucket, then it's also rational. All right, last one, cubed root of 8. Ooh, is 8 a perfect cube?
No.
Yes.
Yes.
It is 2 cubed. Okay, so we can put 2. 2 is a number we learn in kindergarten, right? So it is a natural number, which is in the bucket of the whole numbers, which is in the bucket of the integers, which is in the bucket of rational. All right, I am gonna give you 2 minutes for you and your elbow partner to put these here. So look at me. Don't write negative square root of 50, just write A, B, C in whatever bucket it needs to go in, okay? Ready, set, go.
Rational, so it's So it's like a negative, like
You're doing A. Also, we match it with those.
Do you put it in both the boxes that it fits in?
So what, if it's a natural number, just write it a natural number. And since this Venn diagram overlapping, then it automatically is in the rest.
Oh, okay.
Okay? So if you're gonna write C right here, just write it right here, okay?
Pi was E. Right?
Yep.
It's 13. Zero be. What would 0 be? The square root of 0, which is 0.
0, yeah.
So it's
Yeah.
oh. What's up? It's negative. Wait, it's 30.
Wouldn't it still be negative 34?
It would be negative 34.
Just an integer. What is this one? 3 minus 1.
Oh, cross out K, and cross out M.
3 right? Let's just square root of 4, 2. Jay, which one should you put in which?
Okay, let's start talking about these. Okay, negative square root of 50. That is gonna go in an irrational. 50 is not a perfect square. B, that is a decimal, or else it doesn't stop.
Yeah.
Sure does. So it's gonna be in the rational. Okay. 8 is a natural number. Negative 11 is an integer. Negative 4 1/5 is gonna be a rational. E is rational. F is pi. Oh, I love pi. The number is irrational. Really not a big like pi either. 1.7, what does that bar mean? Repeating. So this is a rational number. Okay. Ooh, square root of 196. Is that a perfect square? Square root of 196 is 14. So that can be put in the natural number. That's a counting number. Okay. The square root of 0 is 0. So I is a whole number. Negative, absolute value of negative 34 is negative 34. So that is an integer. Ooh, what's 27 over 9? 3. So L can be a natural number. And negative square root of 4, well, the square root of 4 is 2. So this is negative 2. So that's an integer. I want you to turn to page 10. Page 10 is your homework. All of it? All of it. Just like we did. Oh.
Always, sometimes, never.
I do want you to.
Got this right.
Take your stuff, sweetie. Yeah.